No, it'll be fine.
She's just got to copy and paste it to her
It
classroom.
says you're live.
I do pick.
Because he's the one who got it last time.
Is it on Classroom or
There's your Google Classroom.
So then you can,
it's not there yet? We uploaded another. What should I tell them?
just give it a moment. Let me make sure it's working.
We're live. It's
Okay, so you need to potentially copy that link and then insert that link into my Google Classroom.
no, this doesn't work because it's not the right link.
There's a YouTube studio. That's okay. Okay.
Otherwise, I'll just have them go to your channel.
No, I'm the only one. Mom's the only one who can see it.
Why
Right
can't
now.
you just push it public and then I'll tell them to for your
Okay,
channel?
got it up in here now. Can you share that?
I don't know.
Go down below. Share. There's the. That's the streaming URL. Copy that now. Paste that into your Google Classroom.
So you have to add.
Mom.
Just
Just
Okay, that's not the right thing.
can you?
just tell them I'm still working on it.
They're aware. They're laughing at things. I have to go back up because they posted and while I was watching.
Is it set as private or is it set as public?
What I had done is set it as unlisted, and then I invite a link and invite my students, and then they can.
Yeah, I know, but right now, if you go public, you may be able to bypass that and it's just live out there that anybody can see.
That's fine too.
Yes, it's made for kids.
No, it's not.
If it's made for kids, then you can't comment. I want them to be
Okay,
able to
no.
comment.
So go down to education. Change that to education because that's what Mom wants.
All right, it's public.
Gosh, if it's public, no.
We should be able to go to YouTube, type in Mom's name. Click on Mom's channel. No, Mom's channel.
At the top,
Okay, I got it.
Okay, so if you can tell them that they need to search for my name.
right, you may not, can you, does it have audio? Can you hear audio? Yes, it does.
Then I just need to figure out picture stuff.
Oh, now you got it working.
But you can do this. Oh, that's just weird.
Oh, that I can invert. That's just normal. Okay,
Invert.
did that
Yeah.
rotate?
Okay.
Now you have a clear view of your.
Quit moving it around.
It's pointed towards your stove now.
Don't point it toward my stove.
It's
We
pointed
get it.
at you.
Okay,
Okay.
There's only us walking.
well.
Yeah, I'm waiting. I told them they're okay, and it's slowly going down from here. So.
Good morning, everybody, if you're getting
There's
connected.
nobody's watching.
All right, we'll get
Nobody's
moving.
watching you.
I'm leaving because you're stressed and you gotta learn how to.
It's only Chris say, oh, there's 5 people now.
Can I back up? Should I back up?
It doesn't make any difference, Mom.
We are winging this and trying to get this figured out. So if you are joining us, welcome. So sorry for the 20-minute delay in starting. Good thing is you guys don't have any place to go today. So I'll give you guys a couple of minutes to get connected. Again, welcome. Happy Friday, everybody.
We've got 7 people watching, which includes Chris and I.
Okay. So,
8 people.
8.
Welcome, Grace. I just got your text. So I thought I was going to do this as unlisted, where it would just be you guys with the link, but now it's a public link. So anybody in the world who really wants to watch my class today can do so if they're looking for me.
But
So-
I doubt anybody would be looking for
Okay,
you.
no comments from the commentary over there. So welcome, everybody.
Myers are here.
Hi there.
Kidding people.
As we get this going and everybody logs in, we're going to try. I do have some things that I wanted to do a picture-in-picture so that I could show the demonstration as well as have an opportunity to talk to you guys where I'm in a tiny little screen, which is my preference. So Chris is going to be our lab demonstrator this morning. Waiting for some more people to get connected. So again, good morning. Somebody's making fun comments because I'm seeing it.
Tegan found Chris's speech about washing eggs. And someone who's junior assassin has said
I
the
think
same.
that's Jake.
All right.
It is.
So where are we at with numbers?
We are at 14.
All right. So a couple more people are still connecting in. I know Rachel will not be joining us this morning because she is trying to get here back from Iceland. So you guys can be in prayer about her. She has been delayed, hopefully getting home till today. And then, of course, she's in isolation for the next couple of weeks. 15 people. Okay. Giving it a couple minutes. Should do the YMCA. And you guys be kind to me. This is so outside
the
my
comments are laughing about my speech that I posted.
Yes, this was not supposed to be the Dale Family Channel, but it seems like it is the Dale Family Channel.
So the Wiggers are watching together, I think, and taking we have got a few people on. 16 now.
Great.
17 now.
So Kyler, can you open the visualizer where I can do the camera in camera or not? Is that not going to be an option
No.
for us today?
It's not going to be.
All right, just to let you guys all know, we really did try this in the last couple of days. We demonstrated some stuff. Carissa was my guinea pig. We had live stream going at home looking cameras. And yet this morning when we tried to do it, it wasn't working. So also some of you guys are in different time zones on your computers or different things. So I had scheduled it for 8:30. Even on mine, it showed automatically as a mountain time zone. So it showed it scheduled at 6:30 this morning. So little tweaks so that we're getting things figured out. A couple of housekeeping things. Thank you guys to all of you who sent me your homework already. So I will get those things checked off. You will not be getting those things back because you still have them, but I will let you know what your grades are on the labs. If you are missing homework, I will let you know and just kind of make some assumptions that it got lost digitally. You can resend it to me. The tests that you guys will be taking, I would like you to snail mail them. So go back, check my previous email this week for your instructions on how to do that. Basically, you're going to put the address on it, get it postmarked by the Friday of that week that it's due, and get those in the mail. The reason for that is when things are done electronically, sometimes it's not as clear of a picture. So I want to give you guys the benefit of any little marks, whether it be a positive or a decimal or whatever, and that way I can grade it a little bit more accurately if I have those hard copies in hand before I get those graded. No quiz today. However, 2 weeks from now, you will have an online quiz. I will get that figured out. Hopefully we can just do it through Classroom and do it. 18 people on, so we're still waiting for a couple more people. Hopefully we
How
will,
many people will you have?
potentially 19. So there's maybe just one. Actually, no, that might be right, because if like some of the families are on together, we might be good. Okay. So again, good morning. When you guys are sending me your homework digitally, please put in the subject line, chemistry, and the date. That way, as they get in, I'm going to put them in a folder for when I actually get them graded, and we'll have an opportunity to get those things back to you guys. What we are going to do today during our time together is I have Carissa, who's going to be helping me with lab, and Kyler's kind of manning my technology over there. So shout out to both of those guys helping me out. We will talk through some of the concepts of the things, and then we're going to actually be doing some of the practice problems in the back of the book, going through those things with reaction rates, making sure you guys are comfortable with that material. 2 weeks from now, we will again meet online, and we'll go through the entire chapter, making sure that you guys are comfortable with the material as before you guys take your test the following week. If you guys have questions, so one of the reasons why I did this live stream is that you guys could type in questions for me. I have, again, my kids are kind of on computers watching. If you have questions, I can respond, and that way everybody can see what we're doing. Anything that I answer for one might help out another student. So if you have questions about the things that you've read about so far this chapter, let me know. Just kind of type me up a question real quickly and we'll go through them. I will tell you, we will already go through those charts and reaction rates and how to figure out the orders, how to figure out those things. So be prepared. Do have your books close by, because we will be going through lab stuff. We will be also going through, again, those extra practice problems in the back of the book. Questions, again, type them out. My kids will let me know. Why don't you guys open up your textbooks to the lab that we're going to do? We're going to talk about reaction rates, and
Tell me what pages.
I'm going to move the camera around so you guys can actually see what we're doing for that. In your textbook, page 460, 461, and we've got things kind of set up here. So again, Carissa, do you want to come and be
Oh,
my girl?
okay.
I will talk. You guys will still hear me talk. Might be instructing Carissa as we go.
Yay.
All right. So if you guys want to, you can do this at the same time as what we're doing. Otherwise, you can watch and then go back and do this on your own. Good or bad is you guys actually have a little bit of additional time on your hands. Probably, because there's, again, no place to really go. So enjoy the family time. Good thing is you guys can still connect it digitally with each other, still communicate, so you're not completely isolated. All right, so the things that we have out today, hopefully Kyler's got the camera so you guys can see them. We are going to do both the lab for experiment 14.1 as well as a demonstration for 14.2, I believe, is our next thing, as just a catalyst demonstration. Lab write-up, you do need to do for 14.1. So again, we talked about that last week. So you guys should be able to do those things at home. Doesn't require a lot of additional things than what you probably have in your home. So lab write-up for 14.1 is required. 14.2 is not. Question for you guys. Do I need to talk slower, or am I okay? How's the feed?
No, you're good.
Okay.
You're good.
We're
No, you're
good.
good.
All right.
Continue.
I
We're
hear
good.
we're good, so we're gonna keep going. So again, we're following the procedure on page 461. So we are going to go ahead and get a small beaker. We're gonna start heating it up. I will let Krista do that. So I'm gonna again just kind of be out of the picture. She's gonna be on it. You're gonna have to kind of figure this out a little bit. Otherwise, you can actually probably microwave it too.
Mom can also assist in the video camera to also see exactly what she's doing. But Mom, you're right in the way.
So you're gonna, Krista, you're gonna need to put water, if you're gonna do it as a double boiler, you're gonna need to have water in the pot as well as there. You guys could do this in the microwave as well, because basically you're just needing to heat up water, then you're gonna put the test tube in it. So she's kind of doing hers as like essentially like a double boiler, and that's fine. So as that's going on, we're gonna go on to step number 2 is we're getting our water heated up. Again, she's going to use gloves today, even though gloves are a hot commodity, because we are using the toilet bowl cleaner. It's got, as you guys know, hydrochloric acid, which is, if you get it on your hands, can be give you an acidic burn, especially those with more sensitive hands. So if you happen to splash it on anywhere besides your gloved hands, just make sure you rinse it off very quickly and rinse it with lots of water. So following the procedure, we're on step number 3. Fill 3 of the test tubes halfway with the toilet bowl cleaner. We'll call these test 1, test 2, and test 3. Okay. Just from,
That's more than half.
okay, so just transfer it. You guys will need to then mark these so that you know which test tube is which. Now you can label them 1, 2, and 3 as long as you're keeping track of them. Just to let you know, if you have glass, a Sharpie, believe it or not, permanent marker will work and it will wash off. So you guys are welcome to do that.
I'm
We're
making
gonna
a
get those
mess.
marked.
I need paper towels.
I'll get you something.
Bit stream glitch. We're fine. Oh, it feels so weird watching it in full double time.
You realize you're talking?
I
and
know.
People can hear you.
Yeah. It doesn't pour out very nicely. So
Okay, so what we can do is you can dump some down the drain if you need to, Krista. So you
No, I
can
got
have
it.
equal amounts in each test tube.
but this one's bigger than the others, so
It probably has the same dimension across. It's just a thicker glass.
yeah, that's close.
All right.
Okay, and then I have the little bit in that one.
Okay. So why don't you go ahead and we're going to get those labeled so you can keep track of them using your Sharpie.
After I clean up all of the lovely mess I made of toilet bowl cleaner.
To answer your question, Kayla, I would prefer that you guys do this on your own. However, if you do not have
This
things
is
at home
4
to
and
make
this
that
is
happen, however you label them.
I don't remember, I think.
4 is the one that is only an eighth of the way through.
Oh, well.
Because you're going to kind of change the concentration on it. So again, I would not make a special trip to Walmart just to make sure you have things. But if you have these things at home, go ahead and do the lab on your own, because to do it on your own, you're going to remember it more and it's just better. And it'll be easier for you to write up the lab and take the time to do so.
All right, what's the next step?
All right, so continuing on, we have our test tube set up.
I think our thing's hot.
Okay.
Yeah.
Now I'm going to stick a thermometer in our hot water just to see. Your water
Okay.
is boiling in the outside room.
Yeah,
Okay.
So the whole purpose of this lab is to check and see how reaction rates will change with some of our variables. We're gonna have a change in temperature, we're gonna have a change in concentration, and we're gonna have a change in surface area. We're also going to have our control set up. Of course, the purpose of a control is nothing changes so that you can always compare that back to your original control. We only want to vary one thing with each of our test tubes. So again, comparing them back to our control. Yeah, that's warm enough to deal with. All right, so Carissa has done step 5, which is diluted. She has stirred her test tube, which is step 6. So now what we're going to do is we aren't using a large beaker. We're actually just using a test tube tray because essentially that is just holding our things. Now we're going to take one of our antacids and we're going to split that equally into quarters. Doing our best. I have another one just there just in case she isn't able to split it in quarters and it completely crumbles. Okay. If you're using colored antacid tablets that you guys may have at home, just be aware that they do kind of stain if things bubble over a little bit or kind of react. So that it does stain. So just be careful on that. I happen to have white ones at home, so that's not going to be an issue for us. All right, so number 9 then, take one of those pieces, grind it into a fine powder. We actually have a mortar and pestle to do that today. So she's going to take one of our quarters, she's going to grind that. Now, grinding is going to increase the surface area of our antacid tablet. And increasing the surface area, it's going to allow the reactions to occur. I guess I shouldn't give you the what's going to happen, but she's increasing the surface area. Number 10 is where we're at. Our water is ready. So now go ahead and you're going to take one test tube number 3, go ahead and put it in the hot water. And you can now add your antacid to each of the other test tubes. So test tube 1 is going to be your control. 2
Is powder.
is the powder.
I'm gonna get
3 is the temperature, and then 4 is the diluted. So she's got to add her powder now to the 2. Here, let me hear. I'll get a funnel.
Yeah, that probably works best.
Hopefully, I'm going to hold that. All right. So we're going to make some observations as for what's happening at each. And then I guess I forgot to bring a glass stirring rod home, but even if you just swirl your things, we're going to give it like 5 minutes and we're going to swirl it occasionally, making sure you're consistent in what you're swirling and how quickly you're swirling, and see what happens. Yes. All right, so make some observations of what's happening. I'm not gloved, but I'm going to look. All right. So as you guys are have been going through this chapter, hopefully our reaction today will be what you expect. So again, test tube number 1 is set up as our control. So we're going to compare things to it. Test tube number 2, that was our test tube that we set up with the powdered antacid. Test tube number 3 is our heated up one, our one that we've increased the temperature on. And test tube number 4 is our diluted. So we've actually decreased the concentration by adding water in with it. Okay. So again, looking, and hopefully you guys can be making some observations. Can you guys, Kyla, can they see all 4 of the test tubes as they're there?
They can see all 4 of the test tubes. They can see from the bottom of the yeast to the middle of that, or like part of that book,
Okay.
and part of the sink. Like I can't see the top of that.
So
blender.
Krista, why don't you go ahead and tell them what's happening in case they can't see the bottom of the test tubes for each of those as time's going on.
I can't
We'll give
really
it
see
another-
the bottom because of the angle, but I can move the camera if you'd like.
Or I can just hold it up to the camera. How much more time should we give it?
We'll give it another minute. I set a timer, so not sure if this is going to be exactly 5 minutes, but we should be able to make our observations. So I heard there's some Captain Crunch dilemma in the Gokin household. What else? What other commentary do we have? Wouldn't be a normal lab if we didn't have some, non-chemistry commentary going on.
Okay, well, let's
How's
see
all the
here.
other lab?
Jake's glass split in half. Everybody.
Oh, that's because it's not tempered glass, which means it's not used to heat, which means you should not stick it over an open flame.
Yeah.
And sometimes even if you're using a canning jar, sometimes they will split. Like I'm a person who does can, and even if you do that. So if you're using a canning jar, they can still split. Even we had beakers now because of our stove as it is. Chris ended up using essentially like a double boiler. So she put a pot, had water in it, put her beaker in it, heated it up that way. That is a safer way so that you don't split glass. So sorry to hear that there's been a loss of glass in your family. All right, so let's go ahead. My timer has gone off. Let's make our observations of this. So we have test tube number 1, and
It is completely filled with bubbles.
but
There's still a chunk of antacid in the bottom of it.
okay, so just you probably don't need to.
I'm sorry, Kyla, you keep moving it on me.
Okay, so
I
just
was trying to get it in focus, and you.
so test tube number 2.
Test tube number 2 has some film on and chunkish stuff on the top, but otherwise it looks like it's completely dissolved.
Okay, so I'm gonna swirl that a little bit and stir
Kristen,
it just a little bit to make sure.
the best viewing thing. I can't see.
Probably should have
Here?
stirred this earlier. Can you
And
see this?
I
Because
can.
now we have actually more reaction occurring more quickly because I think we didn't get that stirred in quite right.
Yeah.
All right, so our test tube that I think most of that was actually sitting on the top versus getting mixed in. I don't know if you guys observed that, but I actually mixed it in. It reacted fully and basically bubbled over the top into my sink. So I think that there was probably didn't get stirred in well, but all of it has reacted, and it reacted quickly because there was more surface area for it to react. All right, so the next test tube is test tube number 3, which is again our temperature. So
Okay, so in this one we have a little bit of powder on the bottom, but
I'm going to stir this one too. Oh, warm. Okay. So what happens with it is all dissolved. And again, increased temperature increases the rate of reaction. And so it is
there's
all
no
dissolved.
antacid left
Very
in that
good.
one.
All right, our last one is a diluted concentration of hydrochloric acid. And as you can see, hopefully, it is still reacting. There is more of the quarter that she added to her test tube still undissolved. We can compare that back to our first test tube, and you guys hopefully should be able to see that. Okay. So again, what conclusions can we make? So when comparing to the first test tube, when we had increased surface area, it reacted more quickly. Now that wasn't totally observed until I mixed it in, but it did. The second test tube then, faster reaction because of surface area. The third one was our temperature. Faster reaction, less undissolved antacid in the bottom because temperature increases the reaction rate. Third variable that we were testing in this particular experiment was concentration. Again, she had a small amount of the hydrochloric acid, the toilet bowl cleaner. She added 7/8 water to that, so we decreased the concentration of the actual acid that was in there. Then added our antacid, and of course the reaction went slower because there was less of the hydrochloric acid to react with the antacid tablet. Okay, questions on that? If you guys have questions, go ahead and type them up. Again, if you have stuff at home to do this, I would still like you to do this at home. If you do not, you can take the observations as they are, but I do expect that you're going to write this up fully. Chris and I are just your lab partners, and so you're going to write up the procedure just like you would for normal class time. I'm going to let Krista go ahead and clean this up, and we're going to flip over and talk about catalysts a little bit.
Film you instead of me.
All right, so we're going to talk about catalysts a little bit. And you guys have not read about a catalyst yet, but we're going to do a quick demonstration. Okay, give me a moment. We're going to do a quick demonstration. Actually, you know what? I'm just going to move these over and wait and clean these up afterwards. Where we're going to do some things with, so flip over to page 480. And I realize you guys haven't read this yet. That's okay. It's just kind of a fun reaction. So when you see it happen, it'll help you as you guys actually do the reaction, or excuse me, do the lab.
What should we talk about in our conclusion?
All right. What should you talk about in your conclusion with the previous lab? You should talk about how concentration, temperature, and surface area affected reaction rates. So again, hopefully that should be pretty easy for you guys to make those observations and why that even potentially happens. So talk about those things in your conclusion. Okay. So again, looking at page 480, we are going to put in some hydrogen peroxide into a beaker. What's in this?
That's water.
Okay, so go ahead and dump that. We're going to just put 25 milliliters of hydrogen peroxide
I
in there.
can just see the stuff.
It's okay. So
I
you might be able to zoom the camera back just a little bit.
It is completely zoomed out.
Okay, so
That's a little much.
Honestly, I think it would have been better on the other counter.
all right. So she's going to go ahead and put that in her test tube. All right. So the whole thing with hydrogen peroxide is H2O2. And it is a reaction that will make water and oxygen gas. You guys already read about that reaction. But the reality is the reaction rate of hydrogen peroxide is actually pretty slow. So it decomposes pretty slowly so that you can't see it actually happening. You can't see the oxygen bubbles. The reason why they have hydrogen peroxide in a dark colored bottle is so that it doesn't react with light as well. So it kind of keeps the light from it from increasing that reaction rate as well. So it also has a shelf life because, again, you leave it too long and it eventually will decompose. But what a catalyst does is it actually increases the rate of reaction. So what we're going to do today, oh, it's in a quarter teaspoon. That's probably close enough to a quarter. So looking at, again, at page 480, the decomposition reaction stuff with hydrogen peroxide. So we have our quarter teaspoon of yeast. This is step number 3. We're going to pour it on top of the hydrogen peroxide. So right now, I'm not sure where Kyler's got. Right now, you cannot see any reaction happening with the hydrogen peroxide. It just looks essentially like a clear liquid, nothing happening. But it is decomposing into water and giving off oxygen gas as we are talking. So what I'm going to do now is I'm going to go ahead and I'm going to dump. Give me a moment.
I'm sorry, I missed something that we're supposed to do this lab write up.
There's a question somebody's typing in.
Wait, I'm sorry, I missed something. Are we supposed to do this lab write up?
Okay, the lab demonstration that I'm doing right now for 14.2, no, you do not need to do a lab write-up on this one. You do need to do a lab write-up on the 14.1. All right, so Carissa, what we're gonna do is we're gonna go ahead and dump that in and kind of mix it in.
Your hand's in the way right
And notice what's happening with it. So it goes from basically not reacting visibly to I've added yeast, and it is reacting visibly. Now, yeast is a catalyst, which means it is increasing the rate of reaction, but we're actually not using up the yeast in this particular reaction. It is still going to be there when it's all said and done. So catalysts speed up the rate of reaction without getting used up. They actually decrease the activation energy, and that's what it causes us to go quicker. You guys remember back from module 13, we did those energy diagrams with the endothermic and exothermic reactions. We talked about that hump, that activation energy, or the energy that it takes to make something happen. Well, the way that a catalyst works is that it decreases the activation energy, but it increases the reaction rate. So they speed up the reaction rate by lowering it. So this basically increased our things. I can also tell you this. It is an exothermic reaction. It's got some heat that I can feel. Nothing dangerous or anything, but it definitely has some heat that we can feel as well. Okay. That is that demonstration. What I would now like you guys to do is we're going to take a couple of minutes and go through some of the problems in the back of the textbook in the extra practice problems. So if you guys would open up to page 582, and we're going to look at some of those reaction rate and analyze those things and see what happens with the concentration. So go ahead, get those things out. I'm going to just clean up here slightly. I might move around my camera because I'm going to actually do and show you guys these things. So bear with me. What I'm going to do, Kyler, is I actually want it to, so I can see the problems as I'm working them with my hands. So. All right. So again, it's that much delayed. All right. So again, you guys are opening up to your textbook page. Okay, this is going to need to be so that if I'm.
That's up. Oh,
If it's upside down, just hit reverse. Is it upside down?
yeah, but this ain't gonna work, Mom, because of the way the video stuff. Oh no, it works. It just appears really weird on this one.
Yeah. All right. So again, you guys are opening up your textbooks to page 582, and we're going to actually work these through together, especially like 3 and 4, which are looking at those reaction rate problems. So I'm going to go ahead and move my book out of the camera view, and I'm going to indeed put some paper here for us to work this through. Page 582. Give you guys a moment to
What are you looking for? Your glasses. Mom has to go find her glasses, so just a moment.
All right, so looking at, again, page 582, we're going to start with number 3. The whole thing with reaction rates and analyzing them and figuring out the rate equation for the reactions has to do with looking at the different trials and comparing what actually happens with them. So you can't ever figure out a reaction rate if you just have one trial. Scientists actually have to do multiple trials, varying only one thing at a time in order to figure out what is the reaction rate and the rate equation for different reactions. Of course, I'm going to move you over because I'm going to sit.
You
All right.
want me to monitor the other?
I'm going to kind of assume that we're good here. All right, so we are looking at number 3. It says a chemist does a following reaction rate analysis for the following reaction. So we have 2 and O2. Sorry. Yes. All right, so trial number 1, we have an initial concentration of 0.05 molar of both the nitrogen oxide and the chlorine gas. And then we have a reaction rate of 0.113 of molarity per second. Okay, so that's our trial. Trial number 2. Okay, when you compare trial number 2 to trial number 1, there's one thing that basically is changing in the reactants. So we have double the concentration of our nitrogen oxide. Okay, so it went from 0.05 to 0.1. So we're only changing that. Looking at the chlorine doesn't change. Again, anytime you do an experiment, you only want to change one thing at a time and then see how that changes our reaction rate. So as we double the concentration of nitrogen oxide, what happened to the concentration or the instantaneous, how about instantaneous reaction rate? Okay, did it double? Did it go up by more than double? What happened? We would expect that if it was a reaction rate of 1 or a rate order of 1, it would actually just go up by double. Okay, I'm going to move this back in here so you guys can see what I'm looking at. Is that upside down or right side up?
Right side up, but you can't see the whole book.
I don't need to see the whole book. Okay, so again, I've doubled the concentration here. Okay, and now here looking at the instantaneous reaction rate, what happens? If it were to quote unquote double, it would be like 0.226. But is it 0.226? No, it's actually more than that. So then you should have like oh my goodness, that means that the order is not just 1. It has to be what? It has to be 2 because it is doubled. Now, if it was significantly more than that, what would it be?
I have a comment saying it went up by a factor of 4.
Mm-hmm. So if it went up by a factor of 4, that means it is basically doubled or quadrupled of what it would be if it just went up by 2. So then I want you to compare now trial number 3. Sometimes you have to compare it to trial number 1. Sometimes you actually have to compare it to trial number 2. So looking here at trial number 2 and trial number 3 and comparing it to trial number 1, what changes? So trial from 2 to 3, that stays the same. From 2 to 3, what happens is we have the concentration of the chlorine gas being doubled. If the order, the reaction rate analysis is doubled, we would expect then the instantaneous reaction rate to double. And does it do so? Yes, it does. That means it basically doubles as we expect it to. And that means that we would, it has a reaction rate of 1 for this particular thing. It's a reaction of that. So now what do we have to do to figure that out? We actually are asked to do the rate equation for the reaction. Well, we figured out some things so far to do that, but now I'm going to kind of move my book out of the way and I'm going to go back to my equation. So we have the reaction rate is equal to K the concentration of nitrogen gas. Okay, so this is our basic setup. Now what we need to do is we need to actually figure out, and we've already kind of talked about what happens with the concentration. And when we know that, we can actually figure out so that we know that this is going to be a 2 and this is going to be a 1. How do we know that? We know that when we compared trial number 1 to trial number 2, it didn't just double, it kind of quadrupled. So in the fact that it quadrupled, we know that it actually has a exponent of 2 for the reaction. If it just doubled as it would expect to, it actually has a 1 on there. All right, so now that is the kind of the first step. What do we need to do next? Are we done with what we need to do? No, because we actually have to figure out what the K is for this particular thing. So this is just the first step. This is not where we're done. Now, you can choose any of the trials. You can choose either trial number 1, trial number 2, or trial number 3, and basically plug the concentrations and the instantaneous reaction rate into it to determine what the K is. It does not matter. They should all end up with essentially the same K for it. So I'm going to just choose trial number 1, and I'm going to put those values of the concentration in there. And I'm going to include my units. And I'm going to also take the instantaneous reaction rate for that. For trial number 1. Okay. Now, I still need to rearrange algebraically to solve for K. So to get K by itself, because these are all multiplied units together, I'm going to basically divide the concentrations. So that's going to cancel that out.
Mom.
Okay, sorry, thank you. And if I divide one side, I'm going to divide the other side by the same thing. Oh. Carissa, I need you to go get a battery charger. Okay, so again, that's going to allow you to get K by itself. Then what you need to do is grab out your calculator. Again, order of operations, you're going to square it first because you have 0.050 squared. Then you can do the multiplication division section. So plugging that all in. Talking significant figures, the 0.050 has 2 significant figures. The 0.113 has 3 significant figures, but your final answer should have 2 significant figures because you're going to round.
Their comments make me want some hash browns. Mom's reading all the comments.
All right, guys, commentary. Keep focused on your reaction rate questions and problems. Goofy kids. I'll let you guys continue to monitor and have fun conversations after we get through the trial stuff. All right, so hopefully notice that the variables can be different for different problems, okay? And the reason for that, if you are squaring the concentration, it's going to square the units. If you are having 0 for one of the concentrations. It's going to change the units. If you are having a 1-to-1, it's going to change the units. So just be aware of that. And that actually helps you to understand what's actually happening in the problem itself. All right, let's go ahead and look at number 4 then, okay? So we have, again, our reaction, and we're going to analyze the different trials. So in the first trial, we again have a 0.100 concentration of each of those. We have an instantaneous reaction rate of 0.234. Now, significant figures for those. Those each have 3 significant figures, okay? Trial number 2, what's happening? What are we comparing? So when we compare trial number 1 to trial number 2, we have doubled the concentration of our first organic material. The concentration of the ion stays the same. And then the rate, what happens to the rate? It doubles. Okay, so if we double a concentration and the rate doubles, we know that it is a order of 1 for it. Okay, looking at trial number 2, comparing to trial number 3. Okay, should we be comparing trial 2 to trial 3? What's happening from trial 2 to trial 3? We have halved the organic, but we have doubled the ion. Okay. Should we be comparing trial 2 to trial 3? No, we should not. We should actually be comparing trial 1 and trial 3. Okay. I'm going to give you guys a moment to kind of catch up with me. Again, we want to compare trial 1 to trial 3 because that's where only one thing is changing at a time. If we compare 2 and 3, we have doubled one, but we've halved the other. That is not a good experiment. We need to compare 3 back to 1. One of the things that I should have done for question number 3 is we figured out the K, but we actually, in order to fully answer and do what they've told us to do with it, they actually want you to put it back into the form of R is equal to K, which is 9.0 times 10 to the second. Sorry, I missed that. 10 to the second. 1 over squared seconds. Then we have our concentration of each. And that is the form right here that they would like you to have it for the answers. All right, so we're back still in number 4 again. So we're going to get the original setup. We're figuring out our rate reaction. Okay, so I did tell you when we went from 1, compared 1 to 2, okay, when they compared 1 to 2, it doubled the reaction rate. So we know that this is basically a 1. It did what we expected it to do with doubling. We talked briefly before and we said, all right, don't compare 2 to 3 because that is not a good experiment. We want to compare 1 to 3. And in doing so, we're only changing one thing at a time. When we compare trial 1 to trial 3, our concentration of the organic, the first molecule, stays the same, but the ion doubles, okay? And the reaction rate, it doubles. So we know that we also have an order of 1 for that as well. Okay. All right, so that's what we need to do so far, but we still have to figure out what this K is. Again, you can take either trial 1, trial 2, or trial 3. It does not matter which trial you take. So you choose what you want to do. I'm going to just do trial 1 again, and I'm going to put in the concentrations because we're going to have to solve for that K. And we're going to take the instantaneous reaction rate for that particular trial. Again, algebraically, you just need to rearrange to solve for your K. So I'm going to show you how to do that. Again, these are the concentrations. Sorry, I missed that there. So that cancels out. If I divide one side, I'm going to have to divide the other side. Chris, is there a question?
Nope.
Are we just having fun commentary again?
Yes.
You naughty children. Just kidding. All right. So again, in solving, what we're doing is we're solving for K. We're going to plug this back in and notice that the units for this is different than the units for the previous problem that we did. Okay. 3 significant figures is what we're given. Okay. All right. So again, is this the final step? No, we need to do something additional. We need to actually put it back into the form that they want us to, which is R, and then we're going to plug in the K. We're going to put in the concentrations with the orders. Rate order 1. Okay, and then this is the correct form then for what you guys need to do for questions 3 and 4. All right, do you guys have questions since you guys are all about the comments today? Questions, things that you guys would like me to go through during our bit of a time yet together. I know you guys, most of you still need to complete the lab and do lab write-up, so I won't keep you forever. Are there questions? I'll give you guys a moment, and then I'm going to kind of review a little bit.
How did you get the label for your R in the last problem?
The label for my R. Okay. Okay, so going back, moles and moles cancel out of molar, left, leaving you, this seconds flips to the bottom, so leaving you with 1 of the molarity and second. So again, 1 of those cancels out with 1 of those, okay? That seconds moves to the bottom so that you're left with 1 over molarity per second. If you compare it back up here to number 3, because we have 2, which is like 0.050 times 0.050, okay, we actually have 3 of the different units in the bottom, cancels out 1 of them in the top, leaving you a second, so that you're left with molarity squared times seconds, versus for number 4, we just have molarity times second.
Why did the M go to the bottom?
The M was already in the bottom because we're dividing by the concentration. So to get K by itself in this step, what we have to do is we have to divide it by the concentration with the unit and the concentration with the unit. So that cancels out on the right side of your equation, okay, to get K by itself. Well, if I do it on the right side of my equation, I need to do it on the left side of my equation. Okay, that's algebraically what you need to do. So when in doing so, then if we're just looking at units, we have molarity and molarity. Again, it cancels out. The seconds flips to the bottom because it is in the denominator anyway. So it flips to the bottom, having the good form of algebraic stuff, and leaving you with our units like they are. Does that answer the question?
All right. We have another comment about, can we appreciate how cool Mrs. Dale is? We spent the whole lecture talking about everything but chemistry, and she's not even yelling at us.
I did scold you.
And yes, the question was answered.
Awesome. Okay. Couple of things that maybe you guys missed in the very beginning. If you haven't emailed me your homework, please, again, take a PDF, a picture of it. Most of you guys have phones or whatever. You can take a picture of it and then send it to me digitally. Please put in your subject line that it's chemistry and today's date, the date that it's due. It's always going to be due on Friday. Get those things emailed to me. If I don't get everybody's homework, everything emailed to me, I will double check back with you and make sure, see where things are at. If you guys are sick, can't get around to it, just pop me an email saying we were sick. You know, things have not been good in our house this week. It is important that as we're apart, and for who knows how long that will be, that we keep up to date with getting through our schoolwork. If you kind of get behind, as you guys know, it gets really tough to catch up. For your tests, I would like you guys to get those in an envelope and snail mail them to me, because it is easier for me to grade them accurately if I actually have the physical copy. Make sure that you're including any work. Abigail, I did get your email this morning. Go ahead and just send me your page of work. Just send it to me in the mail. Unfortunately, I have to use 2 stamps. Other questions? All right. If you guys don't have any other questions, enjoy spring break next week. Enjoy some time. I know that this is probably one of the hardest things that you guys have experienced, hopefully at this point, being kind of a bit in isolation. But remember that it is for the overall good. I will tell you this, my daughter, who's an ICU nurse, she is already feeling this stress, and they haven't really even experienced anything yet. So please be in prayer for all those people who are on the front lines, and stay safe, stay isolated, communicate with each other via all sorts of the technology that's out there. One additional thing that I want to talk to you guys about is we have scheduled some presentations that will be in the end of April. We are still going to do those. It's a little bit doubtful that we'll actually be together. But in this day of technology, I think we're still going to do them. And we're going to have to create a way, or you guys are going to kind of have to come up with a way to actually do your presentations for the chapter. Now, anybody who's taken physics with me before.
We have a question. They're asking whether we have homework this week or not.
Follow your schedule, which means you actually, the question is, do we have homework? Follow your schedule, which means all of next week you have off as spring break. Now, if you get bored and want to work ahead, you can, but things will not be due till April 3rd, I think is the date, the next 2 weeks from today. So it is a scheduled spring break. And honestly, chapter 14 is not that terribly difficult, in my opinion. So it's probably one of those things, if you want to get through it and then just have a little bit longer break, you can. Overall, you might want to write up your labs today. It is scheduled for Monday, whatever that day is that we get back to school. But the reality is it's far more fresh in your memory right now than it will be a week or 10 days from now. So it's up to you. It's not due until we get back. All right. So I was talking about presentations. I still am going to want you guys to do presentations, and you are going to have to be more creative. Kind of like I have never thought that I would be a live YouTuber to teach a class. And guess what? I'm doing it. So we're working through some kinks. You guys will probably have to work through some kinks to figure out how to do that.
To use Zoom for our presentations.
Okay, there was a suggestion to use Zoom. I kind of looked at Zoom a little bit for doing all of you guys. Good or bad is it's a different format. There are some ways digitally, and not everybody has really good online technology in their homes, just to kind of give that. So we'll check it out. What I would like you guys to do is kind of, and I will send out an email and I want you guys to respond back, or I'll do it as a form. I might do that too, since I know how to do Google Forms, where you're going to basically look from chapters 8 through 16 and give me your preferences of what chapter you would like to do a presentation on. So the presentations that will be in the end of, actually, I think they might be May 1st or something without looking at a thing. you and your partners are going to have to kind of present an outline for the chapter and summarize one of the chapters that we have covered this semester. It could be either chapter 8, 9, 10, 11, 12, all the way up through 16. I realize we have not covered 15 or 16 yet. You can still give those as a preference if you'd like to, but I will have you today look at those things and give me your preferences of how you'd like to do that and what you would do. I will do my best to give you your preference, or at least one of your 3 preferences on what the presentation will be. So anyway, you will do a presentation. You'll have about 7-8 minutes to present a chapter. We will have to be a little bit more creative to do so, but there will be an outline of that chapter that will be due to me the previous, like the Thursday night, and I'm going to send those things out to you guys. Because everything is being done digitally right now, you guys will have the opportunity. You could do like a YouTube video and post it to the thing. You could do slides with commentary. You could do, so there's going to be all sorts of things that we can do. But today I will send you guys out a form or an email that I want you to look and give me your preference on what you want to do for chapters. And then I will assign them and who your partners are. And then you guys will have to figure that out. You have a month or so to figure it out. So it can and will be done because you guys are awesome. So any other questions?
Everyone's thanking you for letting the class still happen and that you were doing the presentation stuff online for them.
Aw, you guys are awesome too. This is actually, now that we've survived our first one, hopefully we'll do a little bit better on getting it connected more quickly than we did. But thank you guys all so much. I am praying for all of you guys too. Continue to pray for our country. Continue to pray for families. Continue to pray for those who are right now in the real midst of this pandemic too. So that said, absolutely, God is in charge. He is in control. I was kind of humming a hymn this morning of He made streams in the desert. And the important thing is right now in our lives that we just trust that He is still in control, still on the throne, no matter what He takes us through. So anyway, take care, and we will connect. If you guys have questions or whatever, contact me, and I will sign off.